Hi, Chess. This is Kehan. Can you hear me?
Yes, we can hear you.
All right, thank you.
Right, it's time.
Yeah,
So welcome to CATS. I'm Adrian Farrell. Pong Liu, my co-chair, is remote, and Jim, our AD, is also unable to be here. And well, if you look at the mic camera, the remote folks, you'll see that either breakfast is really exciting or lots of other people weren't able to be here either. All right. While out and about earlier in the week, I discovered that Vancouver's the place for cats. So obviously we will do good work and or drink coffee. It's an IETF meeting. You're halfway through the week. You really should know this. Remember that you need to participate well. That means following our IPR policies. That means behaving nicely and being respectful. If you don't understand what this slide's about, please take some time to read it offline and check out on those BCPs. In particular, try to act like a mature adult and just be professional. Trivia, do the Meet Echo thing. If you're in the room, please make sure that you're signed in to Meet Echo so that we capture your presence and so that you can participate and get in the queue when you want to speak. Chong is going to help with the minutes. He's remote, so it's a bit of a challenge, and you may have to go back to the recording to fill it all in. So please help as you go along. In particular, if you make comments at the mic, make sure that they've been recorded properly. Yeah, once you're in Meet Echo, obviously turn your audio and video off if you're in the room, and if you're remote, turn it off unless it's your turn to speak. Join the queue, don't just go and stand at a microphone. Pong, do you want to take this slide?
well, sorry. Do you ask me or
Yep, that's
you
good.
ask? Yeah. Okay. So this is for our deliverables and milestones. We have adopted the use case and framework document, and we are going to refine them. Of course, all drafts are welcome, but please to remember to post them in the data tracker and discuss them on the list. So for the solution drafts in other working groups, or protocol work is fine if it has use case and motivation. But citing cats as a motivation is premature. And note that we have one IPR dis- uh, disclosure, and if you have any comments, please send it to the mailing list. And maybe next. So here's our agenda. We have 4 presentations about the use case and the trials on CDN cloud rendering and V2X, and also for the use case about DevNet. and we will have one presentation about the framework updates, and two about the compute modeling and metrics, which is the most important work currently. And next, please. And then we will have for the middle networks presentation, and for the last four presentations, please remember to keep the time. We just flash it and to note people to read your draft. So any comments on the agenda?
I just want to note that it's a full packed agenda, and I'm going to try to be brutally strict on time.
Okay, maybe let's start our agenda. First one is a use case.
Yeah, so I believe Jim would like to just have
Okay,
a quick word while I sort out the slides.
Yes,
Okay,
thanks, Adrian. I just wanted to let the working group know that if you don't already know, Adrian is planning to ride off into the sunset in Dublin and do some fishing, I believe. So I have taken the decision to add a third co-chair as an interim step to replace Adrian in Dublin. That will be Med Bukader. I will send an email to the list, but I wanted to let everybody know. And I also wanted to take this opportunity to thank Adrian for what he's done for this working group. It's been a really excellent job. So thank you, Adrian. And that's all I had.
Okay, thank you for Adrian.
So, Kihan, I have your slides, and I'm trying to remember how. Don, you're in the queue. Have you got something to say, or have you just been clicking all the buttons? That's all right. Okay.
Chai, can I go ahead?
You can go ahead.
Okay, everyone. Yep. The first presentation is about the working group document, the CAT's problem statement use cases and requirements. So this is the third version of the update. So next slide, please. So the primary updates from revision 02 to 03. We have some terminology update on computing service because there were some discussions in the mailing list before. And also, the most important thing in this revision is that we have added some complementary use cases for CDN, for cloud rendering, and also Internet of Vehicles, just for some informational sharing. So this part is, complementary and temporal. It's just to facilitate the discussion on the CAS metrics and how to use this metrics for CAS deployment, and also a notification that just like Jim said, the Matt volunteered to be removed from the authors list due to a number of limitations. So we thank a lot for his consistent contributions. And next slide, please. So just a quick inform on the terminology change. So we have addressed some comments from the list because there are some questions originated from the meeting in Brisbane about the service in SFC and also what's computing service. So we have made some discussions in the list. We have here are some summarization update on the computing service. So we have basically changed the basic definition and also provided some complementary information because we think there are some differences and similarities between service and computing service. And service is packet based, while computing service is transaction based. Application content is exposed within a computing service, and also the similarities is that both service and computing service can be on path or on endpoint, depending on the service logic or computing service logic that are defined by the provider. So this definition is agreed on by the list and also the co-authors. So if it's there is consensus, I suggest that the definition can be adopted and updated in the other working group framework document. And next slide, please. So here are some complementary use cases we have summarized, and we have been doing and making some implementation and deployment in China Mobile's network, CMNet, uh, and also China Unicom's network. So I will just present on the first two use case, and then CAT for CDN, especially for 4K video delivery. It is being deployed in two provinces in China now, and also CAT for cloud rendering in one province in Zhejiang, China. And the third use case will be presented by China Unicom later on Internet of Vehicles. Next slide, please. So so here are the CAT trials for CDN and cloud and rendering. Next slide, please. Here is the overview of CAT deployment in 5 provinces. We have arranged 5 provinces for different use cases and testbed in China and China Mobile's network. For CDN 4K videos, we have tested about two approaches. The distributed CATS approach has been deployed in 10 cities in Henan, and the centralized approach is for CDN 4K video delivery is deployed in Jiangsu, and the cloud rendering is being implemented in hybrid approach as deployed in 4 cities in Zhejiang, and also we have done some intelligent detection. It's about major is primarily using some GPUs at the edge to do some object detection and video processing. And so this demonstration has been also being done in 2 different approach, and they are done in 2 separate provinces, Guangdong and Hebei. So in each city, we have deployed like CAT ingress and egress routers in different cities with the network link all set to n times 10 gigabytes. Next slide, please. So here is the first use case, the CAT for 4K video delivery. So we have analyzed carefully about this service. So for CDN, we have already know that it's very mature, and it has very widely deployed in every country. And but for 4K videos, we find it that it's a little different, because 4K videos and even 8K videos, they are bandwidth sensitive. And in CDN mode, its service has a very an interesting working mode that the client side, it will the fetch data chunk every 10 seconds and then store locally and repeat. So we find that this service mode might impact the how CATs can behave. And there are already some service level requirements in 4K video delivery, people need smooth experience. They want no lag, no mosaic, no waiting when they drag the scroll bar. So we map these service level requirements to network level and computing level requirements. That it means that we need fast connection of first packet, and we need congestion avoidance, and we don't want to exceed the upper limit of network link bandwidth and server I/O bandwidth. And also we need fast recovery from congestion. And in this case, just as I mentioned, the clients fetch data chunk every 10 seconds from, they can be fetch data chunk distributedly. So in this case, instance affinity might not be needed. We have set some experiment benchmarking like the average size of data chunk in 4K videos is about 25 mega, Mbps to 30 Mbps, and we said that in the experiment we set 300 clients per video requests simultaneously, and the peak value about these traffic is around 75 Gbps to 9 Gbps. And we set the BGP update about the matrix. The time duration is about every 15 seconds, and the every 15 seconds is quite similar, quite close to the time duration about of the client side fetching the data chunk. So I think they can match each other. So in this case, the primary matrix we have used is that on the computing side, the average server load, they can be represented by CPU utilization and in percentage, and also the average utilization of I/O bandwidth of each site also in percentage, and also in network side, the primary matrix are represented by link utilization, also in percentage, and packet loss rate. So in these cases, the delay is not the most important metric because at the client side, the video or data chunk can be cached, but the bandwidth is the most important matrix. Next slide, please. So here is the overview and the overall deployment of these testbed in CMNet in Henan, China. It covers 10 cities. We have deployed the client side and the 2 ingress node in Zhengzhou, and also the egress node and the edge site in each of the other 9 cities. Next slide, please. With the for the same application, we have the centralized deployment in Jiangsu. In Jiangsu, we have deployed in 3 cities. In Wuxi, we have deployed the client side, also cat ingress and the controllers, and also some source station and management nodes. And the egress node and the service side are deployed in Xuzhou and Suzhou, respectively. Next slide, please. Though here are some test cases set for 4K video delivery and some preliminary results. So the test cases is basically based on 2 major metrics. The first one is CATs based on server load. So the test procedures we set in 3 major steps. The first one, firstly, we set 200 clients, fetch data chunks, and get connected. And then after that, we choose one site to improve its to increase its CPU utilization to make it like this site to work. It's when its CPU utilization is very high, may send alert and need to distribute the service to other sites. And then we newly add 20 clients to see the result. The results shows that the difference of the CPU utilization rate between different sites is under 5%. It means that the service of each client is well guaranteed. And the second test case, the case based on server I/O bandwidth utilization. And firstly, we set 200 clients, 5 data chunks, and get connected. And then we newly add 20 clients, and we repeat the second procedure for 5 times to we want to see that the client network traffic become increase in they are constantly increasing. We want to see the result. It shows that the difference of the number of session connections between sites is under 5%. It means that the load balancing, the result of the load balancing has been well achieved. Next slide, please. So another application we have done is CAT for Migu Cloud Rendering. So here we want to first show that the Migu is a digital content subsidiary of China Mobile. So it provides some applications like cloud rendering and other like digital applications in they do a lot of applications. So we choose cloud rendering offered by Migu as a primary application for CAS deployment. So these cloud rendering jobs will be done distributedly in real time. So for this case, the service level requirements, it will need fast rendering. Typically, the end-to-end delay is within 100 milliseconds, and they need batch processing. So mapping to network level and computing level requirements. The first one is that the cloud rendering need GPUs, and they need to consider both transmission delay, instance processing delay, and client-side delay. And I/O bandwidth also need to be considered when packing high-resolution videos. When we have done some rendering, and also in this case, the instance affinity is required. And primary matrix in this case, for computing side, the primary one and the most important one is processing delay. The delay, they are complex. They include encoding delay, encapsulation of packet delay, and interframe delay. They are measured in milliseconds. And second one is GPU rendering capabilities. The capabilities in this case we measure in frame per second. That means we don't want to to grab the ability of GPUs in very raw matrix, but we want to abstract them in frame per second. They can the ability they can generate. And the third metric on the computing side, the average utilization of I/O bandwidth of each site is shown in percentage. On network side, packet loss rate and transmission delay are the two important metrics. And also in this case, that the service side, there are some other like metrics that may be needed to grab. Is the amount of service costs, which may impact the batch processing in this case. So we may use this three different levels of metrics for decision making of the path selection. The next slide, please. So here is the basic overview of the deployment. So it has been deployed in 4 cities in Zhejiang. The ingress node is deployed in Hangzhou, and also the controller, and also the Migu Cloud platform. So each and the other 3 cities with egress node and also the service site. In each service site, there is rendering instance and also some management instance. The computing matrix at each site, that means the rendering capability of rendering instance, will be first notified to the management instance, and each management instance will tell the Migu Cloud platform and upload it to, and the Migu Cloud platform will open an API, RESTful API to the network controller for passing the computing related matrix to the network domain, and then the controller will download all of these information to the ingress node for decision making. It's a hybrid approach. Next slide, please. So here is the quick summary of the 2 use cases that are being implemented. Sorry,
you're well over time now. So what I suggest is the next steps are have a look at this more and progress it and discuss on the list, and then we just need to move on to the next presentation. But
sure. Sorry, agent. Yeah, sure. And welcome discussion in the list. Thank you.
Okay, Xinjin.
Hello.
Hi, go ahead.
Okay. Hello everyone. I'm Xinxin from China Unicom. And my topic is the use case and solutions for the high-speed internet of vehicles. And the next please. Oh, sorry. Yeah. Mm. Today, I would like to introduce some new product and the Apollo Go in the autonomous driving in China. It is a self-driving taxi service now available in major Chinese cities, including Beijing, Guangzhou, and Shanghai. Uh, Through a mobile app, users can book rides in driverless cars that navigate city roads autonomously, regulating traffic signals and managing complex scenarios. Crucially, these vehicles feature remote operation capabilities, enabling operators to take control in emergency, ensure passengers' safety. Uh, for example, consider a case where vehicle encounters unexpected obstacles like children or pets on the road. Remote operators can immediately take action, slowing or stopping the vehicles until the situation is safe. This function requires reliable network connectivity with lower latency, higher bandwidth, and a strong stability for real-time command transmissions. Next, please. The network diagram of remote driving is shown in this figure. The service request from vehicle accesses the base station through wireless signal, enters the UPF for traffic pathing and splitting. Then it is forwarded to the cloud for service processing and goes to the remote console. The remote console operates according to the received real-time status of the vehicle and returns these control instructions to the vehicle. In this process, there are two issues need to be considered. First, IP packets are parsed after reaching UPF. Therefore, the starting point of traffic steering is at UPF, but will not change with the vehicle movement. In this way, when the vehicle is driving under the same UPF, the routing paths will not be changed, and an optimal service site cannot be found. Second, the vehicle carries a variety of services. In addition to remote driving, there are other services like audio and radio. The requirements of these services for computing and the network are different. So maybe the smart driving service should be given priority. Next, please. So there are two considerations. Yes. First, the location of the traffic splitting can be changed closer to the vehicle. In this way, as the vehicle moves, the starting point of the traffic steering also moves. So the routing switching can be achieved as the vehicle moves. In addition, it is necessary to design a solution that can meet multiple types of services. Next, please. So we provide a solution for the international vehicles. First, a device behind the base station is added, which supports the traffic splitting and distributed routing decision. This device needs to calculate the path based on real-time computing status and network status. This needs to use some protocol extension to advise the computing status. In addition, in order to meet the different requirements of various services, the centralized routing decision should be provided at the same time. Also, next, please. This is the hybrid CAS solution we proposed earlier. And we have analyzed and verified the hybrid solution from many aspects. Next, please. First, we conduct simulation test in the lab. Yes, this is a comparative analysis of the computing advancement method. The black line is the distributed method, which is realized through the protocol extension between devices. And the red line is the centralized method, which is realized through the protocol extension between the device and the controller. We can see that as the network scale expands, the process pressure of a device in the distributed method is greater because the device needs to establish the connection with each node. And the centralized method is better because the device only needs to establish a connection with the controller. So next, in addition, the analysis of the routing decision position was performed. The red line is the score obtained by the making routing decision in the centralized controller, and the black line is the distributed routing decision at the increased CAS forwarder. We can see that the CAS server's quality scores of these two methods have their own characteristics. The distributed method basically around 19 points, and while the score of the centralized method unstable. When the network status is really relatively stable, centralized model can provide a higher quality routing decision based on the global view. When the network changed greatly, all services are highly sensitive to the network quality. Distributed mode can provide a higher switching efficiency. So next, please. In addition to simulation test, next chair, please. Yeah. In addition to simulation test in the lab, we also conduct in the real scenarios for the verification on the current network in Hebei, China. And this figure is a network diagram of the solution for the Internet of Vehicles. And these pictures are taken during the remote driving test in the Xiong'an, Hebei. Next, please. The vehicles is driving in Xiongxian Park, and the remote control consoles are respectively in the Rongcheng and Anxin. Through our solution, traffic scheduling can be carried out well, so that vehicles can access a better remote console. So we have next, please. So we have updated the use case draft with this vacation work, and some content in the hybrid draft has also been updated. And any comments and suggestions are welcome. Thank you.
Thank you, and well done on timing. We've got a question from Daniel.
Yeah, Daniel ZTE. It's very good test and use cases, and it's just a clarification questions. I'm wondering if in your test the CAS ingress router will be resided between the radio access and the UPF, and the worst would be would determine the GTP protocol.
Yes, yes, we added the device to do something.
Oh, thank you.
Yeah, thank you.
Excellent, thank you. So next up is Paul.
Hello. Okay. Pink box. This one. Okay.
Yeah.
Hello. This is John Perjung. Today, I will shortly introduce the use cases for the computing aware intelligent transportation systems. Motivation of this draft is I try to improve our current catch problem statement use cases requirement draft. Especially the ITS, intelligent transportation system case, they have a nice some starting point, but I believe with my previous two works can enhance use cases for ITS. So two cases, context-aware navigation protocol and the edge-assisted cluster-based MAC protocol. Even though we prove concept using specific protocols, but this protocol can be used to design our catch for ITS use cases. So as you can see, nowadays software defined vehicle SDV is very popular. You can see nowadays Otosa, they are providing advanced some mode, providing high computing services for, you can see, advanced driver assistance system, ADAS. You can see the driver. So we can overcome non-line of sight, some obstacles. We can exchange message through a CATS, ITS use cases. We can avoid accident. So you can see autos are they providing the operator system for ADAS or other the autonomous vehicle system. Also, European project Eclipse SDV, they are providing some the cloud native services for SDV application development. So we can see this figure shows the vehicular network architecture. So the vehicles can communicate with each other, V2, V. Also, they can get some help from V2I access edge server. So our catch, use cases we can want the service instance to get some help. But my point is some safety driving in autonomous driver or ADAS scenario. As you can see, context-aware navigation protocol case, this figure you can see the SDB1 hit some obstacles. The following vehicles using a LiDAR camera, they detect this accident situation and they disseminate this information to following vehicle. They can change the lane or adjust the speed, and then they can avoid accident or minimize the impact of damage. So the catch case, we can see, in order to this kind of service, we need to get some help because the vehicles are moving in the highway. They report their mobility speed or some direction or driving the behavior to edge side. So edge, the vehicle cloud has some edge or central, but our catch case more focus on the edge server, right? So they calculate and they behavior. They can construct the cluster and also they can adjust some like this kind of accident scenario. They prepare for that kind of some avoidance of accident or the further some damage. So in order to that, so the vehicles interact with the vehicular edge side, and then sometimes they happen, and then clusters, especially cluster header, are pointed by an edge, and then they can avoid the accident. Secondly, in order to this kind of context-aware navigation case, we needed to provide some timely, also reliable communication between the vehicles. So in order to that, we propose the MAC protocol, edge-assisted cluster-based MAC protocol. So basic idea is the vehicles report their mobility information to edge server. Edge server like the vehicular software defined the controller, so they can make cluster like the previous the CMP protocol, and then they can allocate the channel and time slot according to their situation. So the basic idea, you can see Beaker has some accident happen, they can communicate using previous algorithm, right? So in order to do that, we needed to allocate the channel or the time slot. So this one is, so my point is, our current ITS, the use case is a very nice sketch, but we needed to put this kind of the requirement in problem statement. Also, use case we can add this two cases. So next step is I try to improve this text in terms of the requirement and problem. So even though I have the two specific paper and we prove concept, and I believe we can enhance our current problem statement use case draft. Okay, that's all. Thank you. Any question, comments?
Thanks, Paul. I'm sort of thinking about this use case compared to the other extreme, which was the CDN use case that Kihan presented. And it seems to me that the requirements and so the metrics are very different. Do you see any easy way that we can pool those requirements, or are we just saying different use cases have different requirements?
Right, yeah. So because this is a kind of autonomous driving safety issue, so the timely communication, so in that case, the edge server can provide the scheduling for channel and time slot. That also important thing. Also, another, even though we have this kind of real-time communication, but also the context-aware navigation service case, edge can also construct a cluster. In the past, the BQL add-on network case, they are using this centralized way. The forming for cluster take time. Also, vehicle moving along the lamp side or intersection side. So we needed to help the edge. So I believe catch structure is very important for autonomous or ADAS scenarios.
Dirk, please.
Okay. Any other?
Yes, hi, this is Dirk Crossen Huawei. I'm one of the remaining co-authors listed on the use case draft.
Okay.
Going back to Adrian's comment, I would argue that adding use cases to the document that already has quite a number of use cases does make sense, particularly when it has an angle on the additional requirements you would pose. So I would really ask you to focus on the additional set of requirements you may have that the other use cases have not brought to the discussion, because otherwise we're just adding interesting text to the document, but with no real added value. Thank you.
Okay.
Brilliant, thank you.
Okay. So currently, the use cases problem statement case, I cannot see the problem statement and also some specific use cases for this kind of ADAS. Even though some paper is a horizon, but I read through, but still not clearly. Maybe we can using that reference. Also, we can adding two references, and we can that is my purpose.
Okay.
So sorry. Maybe as an addition, generally, I didn't mean to suggest that I'm not supportive of adding this. I do believe your use case actually does add additional requirements. I'm just asking you because you're the main proponent and probably would be the best person to focus on really teasing those requirements out. That's all I'm suggesting. I'm quite supportive of this use case. I like it, but please do focus on and teasing out the additional requirements, because otherwise we're just adding use case text. That's all I meant. I'm generally supportive, but just keep that in mind.
Right, so that sounds to me like your homework, Paul, is to try to suggest the text that would go in as the merge, because obviously they're not just going to take the whole of your draft and cut and paste it.
Right. Yeah.
So if you can then make that suggestion to the authors of the use case document, they can work on merging.
Okay. How to merge, right?
Yeah.
So, okay. I see. I see. Okay. Thank you. Yeah.
Hello, can you hear me? This is a test.
Yeah, go ahead, Tao.
Hello, everyone. I'm Futo from China Academy of Information and Communications Technology. I'm very glad to report this draft on behalf of the writing team. We want to study the application of CAS technology in the industrial internet. Next, please. First, let's talk about the connotation of industrial internet. Basically, it's a combination of information technology and industrial manufacturing. The industrial internet is a new infrastructure, application mode, and industrial ecology with the deep integration among the new information technology, communication technology, and the industrial economy. As shown in the figure, industrial terminals, edge computing, and cloud services are interconnected through the factory network, forming a deployment structure of two levels and three domains. As algorithms become more complex, the connection between industrial terminals and various computing power facilities will become closer. This further leads to the increased importance of collaboration between networks and computing. Precision manufacturing is particularly important in industrial settings. Industrial production tasks are time sensitive, which put forward high requirements on networks and applications, and needs to meet the deterministic requirements in terms of delay, jitter, reliabilities, and so on. Next, please. Based on the above understanding in this page, I introduce the problem statement of industrial CAS. Firstly, we need to introduce industrial production service. Application services are dynamically adapted to industrial scenarios, tasks, and resources. The computation that devices participate in evolves from simple control logic to complex big data decision making. In the application layer of industrial internet, a deterministic service is the combination of network communication process and the calculation process. It refers to a closed loop formed by one or more application communication links and control links. Therefore, industrial manufacturing requires high real-time performance. Secondly, industrial production service needs to be time sensitive. It's necessary to realize the deterministic management of computing power and network resources based on CAS. The concurrent processing of multiple services must ensure the strict requirements of network performances. Thirdly, to address the above needs, deterministic CAS is adjusting network forwarding configurations according to the computing requirements. The traditional network can only control the round-trip transmission process if the edge side blocks the task due to multiple services. The processing delay of the computing processes will increase. Deterministic CAS manages both the communication process and the calculation process accurately, ensuring the indicators of the entire virtual inspection process from the perspective of an industrial activity. Next page, please. Next, please.
Next.
Hello?
Yeah, we're updating here. Are you not seeing the updates on your?
Oh, okay. Next, I will introduce some use cases. First is the computing-aware industrial robots. The automatic manufacturing of soft materials has always been a difficult problem in industrial digitalization. For the sake of unpredictable deformation of the materials, it brings difficulties to the traditional equipment unless it can recognize real-time states of the deformation for products. Furthermore, product lines needs to accurately perform operations and correct the negative effects of the deformation. The execution of complex assembly tasks is in intelligent manufacturing requires the cooperation of multiple robots. The total time is mainly limited by the recognition accuracy and the recognition delay. If the computing power resources are enabled to through the edge computing and the certainty of network edge communication, self-learning and image recognition is ensured through application-oriented deterministic control. The processing complexity, folding speed, and accuracy of flexible objects can be further improved. From the perspective of production process, network and edge computing jointly affect the efficiency of manufacturing process. Next, please. Next is computing-aware virtual cloud terminal use case. Um, it mainly shows that cloud services are control functions migrated from physical devices to industrial cloud, data center or edge, uh, dramatically reducing production line costs. And it's also will needs to uh, control network resources and computing resources to save the time. Next, please. Next use case is about multi-application collaboration. It means the combination of machine learning, big data, and other technologies with the production line is mainly direct deployment and simple interconnection. And the role of advanced algorithms in resource optimization allocation in the life cycle of industrial production is still not fully reflected. Uh, Deterministic cats can solve these problems through multi-application global scheduling in order to ensure the certainty of the entire production business. Next, please. Based on the understanding of the above application scenarios, we have summarized the requirements of industrial CAS. We have adopted the architecture within CAS group. In this draft, we present six kinds of requirements. Uh, First is the requirements for deterministic management of computer network resources service. And then next is for networks. The second is for internal factory computing. The fourth is about external factory computing. Then we need a global management refer to manage various devices and their resources. and achieve collaborative interfaces between devices. Next, please. Our next plan consists of three parts. The first part is to enrich and improve the use cases. Second part is to supplement the requirements. And the third part is to explore CAS technology in the industrial internet. Next, please. This is my first report in this work group, and we hope to collaborate with more interested researchers. This is all the content of my report. Thank you. I'm a little nervous. Sorry about that.
No, thank you. You were fine. Let's take a very quick question from Carlos, please.
Yeah, Carlos Bernardo, just a comment. I don't know if you're aware that is a industrial requirements draft in the DEN networking group, that it may be good that you take a look at that and maybe contribute to that, because there are synergies, obvious synergies between this work and the other work.
So Carlos, I found that hard to parse. So I'm suspecting that Tao had really hard trouble. Try loud and very slow.
Okay. I'm just saying that there is a draft in the DEDNet working group on industrial requirements, working group draft. I'm one of the authors, and I'm just suggesting that he take a look at this and also contribute to that, because there are overlaps between that draft and this one.
Perfect. Thank you.
Thank you for your question. I need to start this for a while, and I will reply you with an email.
Very good. Thank you. So we move on to Mr. Lee.
Okay, it's my turn. Can you hear me?
Yep, it's good.
Yeah, thank you. So John Lee from Huawei. Next, please.
Oops, that one.
So the presentation is quite simple and clear. So it mainly can include two parts. The first one is about the change since last IETF meeting, and then we can discuss the next step and the plan of this draft. Yes, please. So the update summary from the revision 00 to 02, we mainly address the comments from the working group adoption call, right? So we address the comment regarding SFC from Jim, and then we also address the comment from Zhong Peng's comment. I think that is editorial comment, and then we also address the comment from Joe's, some editorial modifications and some technical comments. Yep. So that is quite simple. Yep. Next, please. But we still have a lot of comments or issues to be addressed. I would say that is great, because I see Zhong Peng just create more than 10 issues just before the this meeting, which is very good, because that is the right way that we can record all the comments we received in the working group adoption call and anytime, right? So personally, I will recommend you to share your comments in the mailing list or to the GitHub repository directly. Anyway, just know it down, right? And we can adjust them one by one. So to me, I would say by the end of this year, we will have a stable revision of this draft, I think. Yep. So yes, next please. So then the next step would be we will the others we work together to address the comments one by one. So first of all, the order record comments or issues in the GitHub repository, and if you talk about it specifically, that would be like adding some text to following sections, like section 3.3, 4.1, 4.5, and section 5, which is about the security consideration, right? So yes, and according to the milestone in the chapter, we will have to submit this draft to IESG for publication in next year, right? So let's work together and try to achieve that as soon as possible. Thank you.
Yeah, thanks, Chong. That's good reporting. From a chairing point of view, I'd like to encourage you to push out new revisions more often. Don't just use GitHub to track and resolve issues, but when you've got a bunch of resolved issues, put out a new revision so that people have got something clean to read and work with.
We do.
Yeah,
We do.
okay.
Yeah.
Otherwise, your timing looks good. I would like to encourage the people who are talking about the use cases, and in particular, putting prototypes together and experimenting. I'd like to encourage them to come back to the framework and check that what they're doing matches the framework, or maybe the other way around, the framework matches what they're doing, so that we don't get late surprises as we try to last call this in the future.
Okay. Got you. Yep.
Okay, there's nobody lined up in the queue. So thank you. You've gained us a little time.
Thank you too. Yep. Bye-bye.
All right, this takes us on towards the metrics part of the meeting, which is the bit that I think is probably most important.
Hello everyone, this is Luis. I will present the draft update on behalf of my co-authors, Sabine, Jordi, and Roland. So a bit of recap about the motivation of the draft was basically we departed from the point that in IETF, network information is quite well documented, but it was not the case for the compute information. So with that in mind, we started to work on how to try to identify compute-related metrics that could help us to cover new situations, new scenarios of deployment of services and operation of services. There was some ad hoc work in IETF, for sure, the work in CATS, also some initial work in Alto, and also in OPSO. Apologies for the typo. So, for instance, the MIP about the virtual machines and hypervisors and these kind of things. And for sure, there are other documentation in other fora external to IETF, like Linux Foundation, ETSI-NFB, ETSI MEC, and so on and so forth. So different inputs, and well, the point here was to try to identify what could be the metrics that we could apply to scenarios related for IETF. The problem space that we initiated to cover was the service deployment. So consider metrics for facilitating the service deployment in a way that we can combine compute metrics together with network metrics. And also the service selection, that would be basically the focus of CATS. As a kind of a spoiler for the next version, we also try to cover the service assurance as part of all the service life cycle. And as I said, we will include this in the next version.
I'll do it.
Oh, okay. So going to the updates, well, the draft was presented already in IETF 118 and IETF 119. Now we are in version 06. We have added in this new version a section focusing on Kubernetes. I will comment later on with more detail on this. And we focus on Kubernetes because it's in this cloud native approach way of delivering services, and so it's probably let's say the leading effort from the cloud side. So we started to look at it with care in order to understand what could be the metrics that we can leverage from Kubernetes. We also moved to a specific section towards the annex, and so the references to specific solutions for exposure. So we will comment it not in detail, but we had reference in the previous versions to Alto as a mechanism of exposure, but could be one of the possible mechanisms. So it's not the emphasis of the draft to look at the exposure or the ways of exposing the information. So this is why we somehow moved to that specific section. And then we also covered some fixings, so editorial fixings that are always a matter to do. So, well, give me back because this is the previous deck. I will just comment on the Kubernetes section. So what we detailed was basically understanding what are the Kubernetes metrics, what we can obtain from Kubernetes as today. Also to comment or describe the Kubernetes architecture. So how it could be integrated with the CATS, let's say, framework, and also the metrics at the different levels, pod, node, and cluster. So continuing with the update of the draft, new version will be submitted in this way, hopefully. So it's now the new version is now in the GitHub. So it's just a matter of submitting. In this new version in 0.7, we will consider the service assurance, as I said before, it's not in 0.6, but will be in 0.7. And also we will provide some refinement on the metric dimensions to be considered. And for sure, new editorial fixing because there are yet typos and so on so far. So next steps. We would like to collect feedback from the working group. So the feedback was already for the 0.6 version requested to the chairs and to the mailing list. For sure, we expect feedback today. Also, in line together with the other presentations of metrics. So for sure, there will be feedback to incorporate to the draft. And our idea is to prepare a new version for next IETF. We are considering to go into details of compute metrics from other solutions apart from Kubernetes, and yeah, insisting probably in the service assurance phase, and also somehow provide context of the metrics that we are reporting with the other metrics that are reported in other drafts. So somehow that we can have such kind of overall view, overarching view of the metrics that are in the different drafts as today. And this is all from my side now. Thank you.
Thanks, Lewis. Joel raises a point in the chat which I think bears some attention, and he's essentially saying that we need to be very careful if different CATS applications require the CATS edges to know about a whole range of different metrics for each application, because that's going to give us implementation and scaling challenges. So I'm hoping that as we move forward with this and the next draft on the agenda, we can start looping back into the requirements and consolidate what metrics we need for CATS as a generic set.
Okay, got it. Thank you.
Cool, thank you. The queue is still empty, so we'll move on back to Kihan, especially if I can find the slides. There we go.
And hi, Agent, can you hear me?
Yep, it's all good.
Okay. So this draft is about CAS metric description and definition. Sorry, this presentation. So it includes about 2 drafts. The first one about computing modeling description. It basically includes the consideration about the problems of defining computing related matrix and how we use it. The second one is the newly proposed draft on CAS metric definition. So we have proposed an initial framework for defining matrix and want to see for comment from the working group. Next slide, please. So basically, the update from the previous version on the computing modeling description draft, we mainly modify section 3 and 5. In section 3, we have rewritten the problems we have, and in section 5, we have updated the consideration of how to use this matrix in CAS domain, and how we have also summarized some high-level design principles for define these CAS metrics. Next slide, please. Yeah, for the background, that for anyone who are not deeply involved in the discussion before, so current status about CAS metrics. So what we're facing now, the problems, 2 problems here is that one is the computing resource heterogeneity. That means that there are a lot of computing resource we need to grab a matrix from. And also, there are problems that we are facing from service diversity. That means service-specific metrics are very hard to define. So what we want to do now is to make decisions based on the choice of some default metrics for cats, and we need to define them. And we have got some consensus from previous discussion, the mailing list, that is the computing metrics in cats should be simple, and the number of them should be few. So only metrics that are needed in route selection should be notified to the network. And we have got some candidate metrics, which I will talk about later. Next slide, please. So we have also summarized some design principles about matrix definition. And the first one is simplicity. That means that the computing matrix in cats should be few and simple, so as to avoid exposing too much information of the service points. And second one is about scalability. That means that the computing matrix should be evolvable in the future for future extensions. And the interoperability is also very important, especially for the vendor. They should be vendor independent and also OS independent. And also stability is another aspect which we think is very important, because the computing matrix should not incur too much overhead to design protocols. We want them to be stabilized, and we don't want to redesign protocols in the future. And another aspect is about accuracy, that the computing matrix should be effective for path selection, for decision making. So if we, the raw matrix might be accurate, but if they are very complex. But if we abstract them to be very high level, and they might be not very accurate. So we need a trade-off between these, the accuracy and the simplicity. Next slide, please. We have also there are some candidate matrix. We have some basic consensus on. The first one is the predicted computing delay. It means that the estimate of the duration of processing inside the computing service instance. And the second one is the server capability. You can see it as an abstraction of the capability abstraction value. For example, one server may support 100 simultaneous sessions, and another can support 10,000 simultaneous sessions. You can view it as a kind of capability. And also the third one is the status indication. And for example, like indication of please stop sending new sessions instance A. So we see the third one as an control value to be notified to the CAS domain. Next slide, please. So we also update some considerations of how to use this matrix in CAS domain. So primarily in CAS, the core functional module to make decisions is in CPS, the CAS path selection model. It's located in the ingress node. So two kinds of route policies may be applied in the ingress. The first one is backup mode. So we have only one active route, and others just for backup. And the other one is load balancing mode. Like we can share several routes and for flow load balancing, and they are active at the same time and each have a wait. So the most important thing in ingress, we need to update these policies based on the matrix. So we have proposed some initial mechanism for use this matrix and to distribute this matrix in CAS domain and to update policies in ingress. The first one is to match the backup mode. We use a predicted computing delay, and it will trigger the backup mode on the ingress and lead to a potential minimum latency for client. And the second approach is for the load balancing mode. We will set a load balancing weight, which can be a cardinal value, has been proposed by Dirk in the mailing list. So it can be mapped to server capability and trigger the load balancing mode and the ingress for selecting appropriate routes for the matrix distribution, and sorry, for to steer the traffic to appropriate service node. Next slide, please. So based on these considerations, we have proposed a basic framework for defining this CAS frame matrix. So here is an hierarchical framework. We have 3 levels of matrix definition, from level 0 to level 2. So level 0, we call it raw matrix. So the matrix without any abstraction. So what these matrices are generated, they are no, so you can grab what matrix, like CPU frequency and networking bandwidth and storage read and write speed, and also some delay. So the raw matrix all have physical meanings. And the second level is normalize the matrix in categories. So in this level, we may have some appropriate abstraction on each category. We will get normalized values in each category, like in networking, we have a normalized value, and also in computing, storage, and delay. So in the normalized value, they might not have some physical, detailed physical meanings, but just some value. And the top level is fully normalized matrix. So in this level, is one-dimensional and highly abstracted. It might be a weighted sum and values, different values. So you don't have to know how matrices are abstracted. In this level, you just have a very simple value. We can avoid complexity expression. So it is a hierarchical view of the matrix definition. So next slide, please. We have done some comparison of these 3 levels from different aspects, like complexity, extensibility, stability, and also accuracy. So all of these different aspects also mentioned in the design principles. We can see that from level 0 to level 2, their complexity decreasing, but their extensibility and stability are increasing. While the accuracy from in level 0, they might be good, but when all the matrix are abstracted, the accuracy might be decreased. So we need to have a trade-off between different aspects. And we have some intuitively, we have some suggestions in its definition draft, like intuitively, a level 2 matrix are recommended because of its simplicity, extensibility, and stability for implementation. So, and we think that its accuracy can also be improved by design proper decision-making algorithms. Next slide, please. So for next steps and a quick summarization, so can we agree with making some matrix as the default ones for CATs, which means that all CAT nodes must recognize them, so that enabling the basic and default action. So, and also is the proposed CAT definition and classification method appropriate for decision making? So if question 1 is accepted, can we agree on some matrix to be default matrix that have been discussed before? That is a predicted computing delay and also the load balance weight. So, and we welcome for discussions and comments from the list, because this is very important work currently, and also for facilitate the work for matrix distribution and also other works. Thank you.
Thank you, Kihan. I have to say, from a chair point of view, I'm really, really pleased to see this work. We were struggling, I think, a few months ago, and you've come in and saved us. Daniel has a question.
Yeah, the categorization of the 3 levels service metrics is good. And as far as the level 0, there's actually just a set of networking metrics such as latency and bandwidth with accordingly algorithms. So it will be preferable to use the same matrix as the networking actions, such as latency. So the algorithms as well as the metrics could be reused in terms of the protocols, routing protocols. Yeah, so the level 3 actually the raw metrics should be avoided when we're talking about the propagation of the existing routing protocols. Thank you.
Sure, agree. Yeah, we want to. We just in this document. We want to show a high level overview of all metrics, and then we can decide what matrix we want to define and choose, and which is best for a CAS decision making.
So there's a lot of chat in the chat window. Please read through that because I think there's important information. Something which several of us caught on your slide 4 was to look at all of your shoulds and see whether they are really must. Because should kind of says, well, it'd be a good idea, but we could do something different. And I think many of these cases, you just need to be a bit firmer and say, this is a must.
Sure. I agree with you and agree with the chat. I think maybe for simplicity and also like interoperability, I think we can change it to be must and change the tone to be strong, because this is really very important for for cats. And also I think maybe for accuracy of the last one, I can maybe still maintain should, because up to now I'm not so quite sure if it be must. So for the other like scalability and stability, I'm not sure, but want to solicit for more comments. This is my personal view right now. So, and I think I will look into the questions after the meeting and have some internal discussions with the other co-authors and have put into the list. Thank you.
Yeah, thank you. Jim.
Yeah, just one comment as a speaking as an individual contributor rather than any hats. I find the number 4 to be a little bit problematic, and you might want to think about that a little bit because it's very subjective in terms of what do you classify as too much overhead in protocol design. To me that's kind of a little bit of a meaningless statement because it's very difficult to quantify that. So I don't have any great suggestion for you, but it's something that you might want to consider, because if you make that a requirement, then just remember that any requirement is really there so that an implementer can actually implement the thing. But if they don't understand the requirement, then it becomes problematic.
Okay, thank you, Jim. Yeah.
So I think it's great to be doing this work in separate drafts that can be a focus for discussion. As we go forward, I wonder whether we're going to end up putting metrics discussion in the requirements and framework, or whether we want to keep it separate. And I've got no clear opinion on that, but I'd like everybody to be thinking about that as we move forward. Cool, thank you. We'll move on. Which is back to Lewis, I think. Oops, fine.
Thank you. Hello, this is Luis again. I will present the data of this draft on behalf of my co-author, Mark. And the idea here is to analyze the applicability of CATs to mid-haul networks. So a kind of quick recap of what we are talking about. So we are departing from the scenario where the distributed radio access network follows this radio functional split. So in such a way that we can take part of the processing of the functionality in the A node bits, in A node bits, and distribute it along the network, right? So somehow taking the radio unit, the distributed unit, and the centralized unit in separate deployments and distributed deployments at the end. So what we are focused on is in the mid-haul interface, so also called F1 interface in 3GPP terminology. And here is the point where we want to explore the applicability of CATs. So the CATS framework applicability for mid-haul somehow is summarized in the figure that you can see on the right of on your right. So essentially considering the distributed unit being deployed on top of servers or compute facilities, and the same thing for the centralized unit. In the centralized unit, we can consider centralized unit for the control plane and for the user plane. So essentially what we are referring here as distributed part will be the user plane, even it's not explicitly said in the figure, but with the CUUP. So here the point will be to, along the services running and according to the different metrics that we can observe, to decide what will be the steering path between the DU instance and the CUUP instance. We could have different CUUPs deployed in different sites. So essentially that would be the decision, no? to decide what the steering path to the different CUUPs instances along the time. This could be done from this decision could be done as a kind of application running on the service and management orchestration of the ORAN architecture, leveraging on the functional entities proposed by CATS, essentially the path selector and so. We can consider to have monitoring agents both in the network and in the compute side, so the CNMAs and the CSMAs, so following the same architecture of CATS. And here, just to reflect the metrics that by now, ORAN is considering is CPU average utilization, memory, and energy usage for each of the CUUP's instances. In the draft, we simplify the steering decision leveraging on the network slicing framework from IETF, the RFC 9543. So this is what we are describing in basically in the draft. So I think, okay. Addressing some of the comments received in the previous presentation in Brisbane, we incorporate comments provided by Tianji. We provided this in the draft, this protocol encapsulation view. So as you can see on the top of the figure, we will have the connectivity view between the DU and the CUUP. So traversing a number of network elements, routers, basically. And that would be the scope of the proposal. So how we can solve that connectivity between these two instances. We added a protocol view, but discussing with Tianji, we realized that this is not correct at all. So we will correct in the forthcoming version. And the idea, essentially the applicability of CATs would be what you can see at the bottom of the slide. So basically solving that connectivity, that traffic steering, simplified here with a VPN, MPLS-based VPN, but could be whatever other kind of solution. So this is just an example. So we have incorporated this view, but yeah, we need to correct because it's not exact at all. Also, we have included in the draft some example using the IETF network slice service. So considering how to define the steering paths leveraging on the network slice service, so essentially considering a hub and spoke VPN solution as an example, where you can see the connectivity matrix, let's say, between the DU on one hand, and then the different instances of the CUUP. And then also in the bottom part, an example of how could be the enforcement of the path steering, leveraging on the match criteria that in this case would be the IP prefix of the CUUP. Okay. So in summary, the decision of the path selector would be essentially what would be the match criteria to be applied so that we can leverage in one of the parts of the network slice for a specific CUUP instance. So next steps, we are progressing in parallel an effort of describing the CATs as a mechanism in the ORAN Working Group 9 specifications. Working Group 9 is working group in Oran dedicated to the transport network, to the X-Call segment. We maybe consider that a liaison statement could be useful for progressing the work so that we can work in parallel. So we are doing this informally, but maybe it could be interesting to have a formal binding of both works. We would like as well to collect more feedback from the working group. We already had from Tianjin in the past, but yeah, we would like to have more working group to understand if this is interesting, useful, and so. And yeah, basically we expect to prepare a new version. We would like to keep working on the interplay between the Oran orchestration framework, the SMO, and how it could interact with the CATS entities, the path selector, the CNMA, CSMA, and so on so far. And maybe also could be interesting to consider if the adoption of the document could help on the task of considering CATS for Oran. So if that is the case, our idea would be to go to next IETF and ask for adoption. But yeah, for sure, this is something matter of the chairs to decide. Thank you.
So thank you. We put this where we did in the agenda because we felt that this is less of a use case and more of an applicability. But please, nevertheless, as you do this work, try to feed back into the requirements and the framework if there's something that doesn't sit right or feels odd. Tianji.
Yes, Tianji, CMCC, as Louis mentioned, we had a lot of discussions about the work here. And then I think for the ORAN, because I have quite a few colleagues in the ORAN Alliance as the TSC members, I talked to them about the ORAN, the current spec. The current spec, although it's using, so far it's using the static mapping, but they told me it does not prevent they're going to use the dynamic mapping between the DU and the CU. So this is some valid case for the CAS scenario. The second thing is also I involved in the 6G discussion, because in the 6G there are some, for 5G there's like a disaggregated for core network, and then but for 6G the similar things might be considered. Actually, it's being considered for the RAN side. So when we have the disaggregation on the RAN, this one will also play into the picture. So I think this is some valid case. Yeah, thank you.
Thank you.
So I've taken an action that the chairs will talk to the AD and work out what the best way to communicate with ORAN is.
Thank you.
Right. So the rest of the meeting is like we did last time, much more of flash talks, which you could see as, here's a quick brief on what my draft is, and please go and read it a little more. So Zhongpeng.
Hi, can you hear me?
Yes, good.
Oh, okay, thank you. Hello everyone, I'm Zhongpeng Du from China Mobile, and this is a draft about aggregated metrics on the egress node and the corresponding routing mechanism. In this draft, we do not talk about how to merge the metrics, but we assume that the metric has been aggregated on the egress, and it will cause some problem about routing. Next page, please. And in this page, we talk about the general procedure of kites. In the first step, the client will send some packet with a destination address as a SID, or called the service ID. It's any cast address. And many places in the network, for example, the MEC1, MEC2, and the MEC3 all support this service, and they are service point, different service point. They all can fulfill the job, and the ingress will do the load balance job and choose one of the service point for the client. And next page, please. And for the step 2, we have two detailed steps. And The first is that the ingress will select a proper egress and tunnel the packet to it. And after receiving the packet, the egress will need to forward the packet to a proper service point. Next page, please. And we have two options here. The first one is that we have only one load balance port. It to see the ingress. It will decide both the egress and the service point and tunnel the packet to the egress with a proper endpoint dx function. It's about v6 function, and we have a draft for it. It's CAS data plan segment routine mechanism, and we also have another option here. The ingress can only decide the egress, and the egress is responsible for selecting the service point locally connected. Next page, please. And for this option, we have two load balance points. The ingress will do the first load balance job, and the egress do another round of load balance job. It will select the service point locally connected. Next page, please. And if we use this option 2, we need to assume that the egress can aggregate the metrics from different service site. In CAS, we have 3 levels of computing metric can be considered. The first is that we can report the metric from a service point. And the second level is that we can report the metric aggregated in the service site level. And we mainly focus on the third point. We merge the metric at the granularity or egress node level. And this third one is for option 2 described in our draft. It of course more complicated, but the advantage is that it can reduce the metric information that need to be announced in the network. Next page, please. Our next step is one to call for comments and contributions. That's all. Thank you.
Thank you. Good timing. I see two things going on in this draft. One is about the packet marking with service ID and how that's forwarded. And the other is about metrics and consolidation of metrics. So please have a look at the discussion that's just been going on in the chat window about metrics, and also think about whether you can take some of your thoughts about metrics and move them into the drafts we had earlier that were discussing metrics.
Okay, thank you.
Okay. Moving onwards.
Yeah, can you hear me?
Yes, go ahead.
Yeah. This is Taiwan Lin from New H3C. This draft is about the source metric distribution based on BP. Next page, please. Yeah, so background, as shown in these pictures, whether centralized models or dispute models, the transmission of source metric is crucial. Next page, please. Here is a list of current way to dispute source metric information. First, API interface method. The source metric can be transmitted using RESTful gRPC and YAML protocol. This method is suitable for centralized models. Second, the source discovery and registration center method, such as Lisp. This approach lacks the material application and has has a limited scope of use. Certainly, routing protocol method, we can extend BP to carry the source metric by adding new BP attribute or new address family extension to support the transmission of source metric. This document will discuss how to extend BP to support the distribution source metric. Next page, please. I will explain why the new BP address family was chosen based on the following four aspects. Firstly, in terms of scalability, CSID can only be any cast addressed for original BP address family, and the source metric can only be expanded through BP paths. Second, in terms of isolation, the period update of source metric will affect regular root update. When a regular update and the cache root are updated at the same time, and the cache root is in the middle of the regular root, the converse of the regular root will be affected. Thirdly, in terms of performance, period changes in source metric cause the most source metric to be different, thus make it impossible to pack multiple cache routers in one update message. About the limitation of the original address family can be optimized by defining a new address family. Next page, please. The design goal of the new BP address family are as followed. First, it can optimize the impact on the existing router propagation. Second, service CSID are not limited to any cast IP address. Thirdly, it can improve the efficiency of sending period service metric update. Fourth, it supported on-demand sending and could control the propagation scope of service metric. The table clearly showed the difference between the new address family and the original address family. In summary, the new address family offered better isolation, scalability, and performance compared to the original family. Next page. In brief, the new address family is more extension in terms of NRI design. Next page. By using different type of router, the new service address family could work flexible. The dynamic service metric router filtering capability can be achieved. Next page. This use case shows how the new address family works. Yeah, next page. Yeah, that's all. Thank you. Any questions, comments are welcome.
So we have Linda in the room just making her way to the microphone.
So it's Linda Dummer from FutureWay. So you are aware in IDR there's a working group draft on the metadata path attribute, right? Which can carry the service metrics for a particular service. Well, maybe you can look at that draft and then compare with that, because there are lots of considerations when you are adding service metrics for a particular service, a particular service ID. And not only that you carry the information, because the goal of carrying those information is really for the ingress router to make path selection, right? So the IDR's path attribute is one way of doing it, and I think it's better to compare with that and see the pros and cons. Thank you.
So Linda, maybe you could send a note to the mailing list with a pointer to that draft.
Okay, I
Yeah.
will do.
Thank you.
Yes, thank you.
Thank you, Chang Wang. I've just got lost. There we are. Green challenges in cats.
Okay, can you hear me?
Yep, that's good.
Okay, thanks, Adrian. Hello, everyone. This is Jing Wang from China Mobile. I'm here on behalf of authors to report the draft about green changes in cats. Next slide, please. Okay, compared with version 01, a co-author from Huawei was added to the version 04. In addition, we mainly modified the section 3. Next slide, please. Okay, before introduce the new challenges, let's review by considering green in cats. As we all know, reducing carbon footprint to net zero is one of mankind's grand challenges. With the continuous development and the progress of the internet, a large amount of computing resources is required to complete data processing, which would produce a lot of energy consumption. CAS is about the process of selecting source instances for directing traffic to them based on observed metrics for both computing and networking. So green CAS is worth exploring. Next slide, please. Okay. There are 6 green challenges in CAS. The last 2 challenges are new additions. The first is evaluation of computing equipment energy consumption performance. The second, using of green energy. Next slide, please. Okay, let me introduce the first new challenge. The first new challenge is evaluation of computing equipment energy consumption performance. The energy efficiency level requirements of computing equipment also be considered when performing traffic steering. The higher energy efficiency level, the less energy is consumed by the same service. The lower the energy efficiency level, the more energy is consumed. When the service provider wants to prioritize energy consumption, it can schedule the user request to the service instance with the highest level. But there is no standardized definition of computing equipment energy efficiency level. Therefore, it's difficult to consider the computing energy efficiency level of computing equipments when performing traffic steering. Next slide, please. Okay. The second new change is using of green energy. Green energy, also known as clean energy, refers to energy that doesn't emit pollutant and can be directly used for production and daily life, including nuclear energy and renewable energy. Renewable energy refers to energy sources that can be regenerated from raw materials such as hydroelectric power, wind power, solar energy, bioenergy, uh, geothermal energy, and tidal energy. Renewable energy doesn't have the possibility of energy depletion. Therefore, the development and utilization of renewable energy are increasingly valued by many countries, especially those with energy shortages. The development of green cats cannot be separated from the use of green energy. The more green energy is used in cats, the least carbon footprint is emitted, and the greener it is. The consideration of the consumption of green energy for equipment in traffic steering is incomplete, and further research is needed. Is needed. Next slide, please. We will consider how to use green energy in cats. Welcome more people who are interested in the vehicle. What's more, there is also a green bulb today. It can also be discussed in combination later, if necessary. Thank you. Any discussion and comments?
Thank you for that. Thank you for flagging up the green buff, which is after lunch today. I just want to note that green metrics in cats are currently not in the charter, but I think it is worth having this draft going on and working on it in the background so that we're aware of what could be done and how we might extend the charter as we go forward. Oh, we have two people in the queue. If you can be quick, please, Daniel.
Yeah, Daniel Huang, ZTE. I think it's interesting, and CATS is designed to steering traffic upon some strategies. It occurs to me the working group now is working on is experience prioritized the steering strategy, but I think we can add the green prioritized strategies into CATS steering strategies. Thank you.
Thank you.
Lewis.
Yes, one quick comment from my side. In the previous presentation I made about the Oran use case, the F1 interface, the mid-haul, I refer to the fact that in Oran, the energy consumption is also considered as a metric. So it could be an example of usage of this green metric. So maybe we can explore that particular example. Thank you.
Thank you.
Okay, thank you, Jim. And last on our agenda.
Hello?
Yeah.
Could you hear me? Hi.
There are your slides.
Okay. Hello everyone. I'm Cui Wang from China Unicom, and I will give the presentation on behalf of my co-author Yifu. And our topic is security considerations for computing-aware traffic steering. Next page, please. Our first concern is about secure paths and service requirement, and we suggest that the service and the network metrics may include the security-related capabilities, which could be used by the CAS path selector to compute paths with security guarantee. So the clients with high security requirements, such as bank, hospital, government, etc., could choose the service with desired security attributes, and then they can achieve dependable forwarding on top of only devices that satisfies certain trust requirements, and it will avoid the risks of traffic eavesdropping, sensitive data leakage, etc. Next page, please. Our second concern is about the requirement for authenticity and encrypted protection mechanism of service announcement. We suggest that there might be mechanisms that provides protection about the integrity and service authenticity of the messages in the service announcement. Because it could be because without the protection, it could be exploited by malicious service to reroute the traffic, and it may lead to some incidents such as DDoS attacks, phishing attacks, or sensitive data leakage, etc. Next page, please. Our third concern is about the requirement for authentication and integrity protection mechanisms in CAS communication. Because a malicious CAS forwarder could tamper the messages in the communication between forwarder to forwarder or forwarder to CSMA, and this will have a ripple effect on routing and path computing of CPS. So we suggest that the CAS solutions could support authentication and integrity protection mechanisms between the communications, such as between the CSMA and the CPS, or between the CPS and the ingress CAS forwarders. Next page, please. So our question is that, does CAS need to consider security issues simultaneously? Thanks for your listening, and more comments are welcomed. Thank you.
Yeah, so thank you. I saw several things in there that are interesting. One of them is making security capabilities and status yet another part of the metric that can be folded in and normalized. So please look at the discussion in the chat that's just been going on about normalizing metrics. And it's a very similar discussion to green metrics, and is at least initially out of scope, but something we should be watching. But the other part of that is security, and the whole of our work, from requirements through framework and solutions when they come, desperately needs to consider security, and we've really not been looking at it. So please see if you can help there. Right, I want to thank everybody for being absolutely perfectly, rigorously on time. It gives us exactly 2 minutes. If anybody wants to say anything, come to the queue, make a general comment. Otherwise, you can have an extra minute and a half for your lunch. Going once, going twice. Okay, well, then I'll leave you with a homily. Do not make your chairs depressed by waiting until 2 weeks before Dublin before doing really, really good work that's helpful. Please try to actually do stuff in the interim as well, so that our stress levels are reduced. Thanks, and see you in Dublin.